Chapter 1.4.1.7 User Namespaces. Kubernetes v1.3 beta introduces user namespaces, which isolate the user running inside a container from the host. This feature allows a process running as root in a container to operate as a non-root user in the host, reducing the risk of a compromised container causing damage to the host or other pods on the same node. User namespaces can prevent exploitability of certain security vulnerabilities, with potential to mitigate future risks as well. Before you begin, the text discusses the requirements for using user namespaces in Kubernetes pods. It explains that file systems used in pods volumes must support ID map mounts, with popular file systems that support ID map mounts listed. Additionally, the container runtime and its underlying OCI runtime must support user namespaces, with specific versions of CRI-O and Containered mentioned as compatible with Kubernetes versions 1.25, 1.31. The text warns that many OCI runtimes, such as runc, do not include the necessary support for user namespaces in Linux pods. For those looking to use user namespaces with Kubernetes, it is recommended to check the compatibility of the container runtime being used. For example, CRUN version 1.9 or greater is recommended, while Containered v1.7 is not compatible with the user's support in Kubernetes v1.27 to 1.31. Users are advised to refer to the documentation of their specific versions of Kubernetes and container runtimes for compatibility information. Overall, the text emphasizes the importance of ensuring that both file systems and container runtimes support user namespaces to effectively use this feature with Kubernetes pods. User namespaces in Linux allow for mapping users in a container to different users on the host, with capabilities granted only within the namespace. Pods can enable user namespaces by setting .spec.host users to false, with the kubelet assigning unique host UIDs, GIDs to each pod on a node. When user namespaces are active, all user-related fields in pod.spec refer to the container's user, using UIDs, GIDs in the range 065535. Files with IDs outside this range are seen as belonging to overflow IDs, typically 65534, but cannot be modified even by the overflow user. Applications that run as root without accessing other host resources should work as usual when user namespaces are enabled. Understanding user namespaces for pods. The text discusses how container runtimes use Linux namespaces for isolation, with some opting to use VMs instead. When creating a pod, multiple namespaces are utilized, such as network and PID namespaces, for isolation. Using a user namespace can further isolate users in the container from those on the node, allowing containers to run as root but be mapped to a non-root user on the host. This abstraction limits containers' capabilities on the host, reducing the potential impact if a container were to escape. Additionally, user mappings ensure that users in different pods are unable to affect each other. Capabilities granted to a pod are restricted to the user namespace, rendering them mostly invalid outside of it. For instance, a pod with capsys module cannot load kernel modules, and capsys admin is only valid within the pod's user namespace. Using user namespaces prevents a container breakout from granting root privileges on the node, as capabilities do not carry over to the host. For more information on how user namespaces affect container security, users can refer to the man page for user namespaces. Set up a node to support user namespaces. The default behavior of the kubelet assigns pods UIDs, GIDs above the range 065535 to avoid any overlap with the host's UIDs, GIDs, which is crucial for security purposes. This prevents vulnerabilities like CVE 2021-25741, where a pod could potentially read arbitrary files on the host. To configure a custom UID/GID range for pods, the node must have a user named kubelet, the binary get subids installed, and a configuration of subordinate UIDs/GIDs for the kubelet user. The subordinate ID range for pods must start at a multiple of 65536 and be greater than or equal to 65536, with the count being at least 65536x, the maximum number of pods that can run on the node. It is important to assign the same range for both user IDs and group IDs, ensure no overlaps with other assignments, and have the subordinate configuration as just one line. This setup is designed to prevent accidentally insecure configurations and enhance the overall security of the Kubernetes environment. Integration with pod security admission checks. Kubernetes v1.29 Alpha introduces a feature gate called User Namespaces Pod Security Standards that allows for the relaxation of pod security standards in a controlled manner when using Linux pods with user namespaces enabled. This feature gate allows end users to opt in early, but admins must ensure that user namespaces are enabled on all nodes in the cluster. This feature does not pose a security risk, as the root inside a pod with user namespaces does not map to a privileged user on the host. Certain fields are not checked for pods in these circumstances, including spec.securitycontext.run as non-root, spec.securitycontext.run as user, and others. Limitations. When a user namespace is used for a pod, it is not permitted to use other host namespaces. Specifically, if host users is set to false, then host network, host IPC, and host PID cannot be set to true.